Now let's go through one complete simulation example problem. The Transportation Security Administration, TSA, is responsible for airport safety. On some flights, TSA officers randomly select passengers for an extra security check prior to boarding. One such flight had 76 passengers, 12 in first class and 64 in coach class. 12 in first class, that's the more expensive seats, 64 coach class, the less expensive seats. Some passengers were surprised when none of the 10 passengers chosen for screening were seated in first class. In other words, they suspected special treatment was being given to first class passengers. We can use the simulation to see if this result is likely to happen by chance. State the question of interest using the language of probability. Okay, so how would I write this? How likely is it that a random sample of 10 people from this passenger list contains no one from first class? Okay, that's what I'm wanting to find out. Okay, the next piece says, how would you use random digits to imitate one repetition of the process? What variable would you measure? Okay, so we need a complete description of the process here, and this has, just like we talked about earlier in the course, this has to be a description that someone else could follow exactly just by your description. So it has to be nice and clear and detailed. Okay, so here's what we're going to do first. First of all, we have to assign numbers. So I'm going to use a random digit table. I need 76 passengers. So I'm going to assign 01 to 12 to be first class passengers, 13 to 76 to be the coach passengers, and ignore all other numbers, 77 through 99 and 00, because those don't represent anybody. Using one line of a random digit table, choose 2-digit numbers between 01 and 76, ignoring 77 through 99 and 00 until you get 10 different numbers, skipping repeated numbers. Record the number of first class passengers. Now, why is it that I'm skipping repeated numbers when before, in other examples, we didn't skip repeated numbers? Well, in this case, we're not saying a certain percentage of the passengers are in first class and a certain percentage are in coach. We're saying there are exactly 12 people in first class and exactly 64 people in coach. So each number represents an individual person that is a passenger, and so once we have drawn one passenger, we cannot draw them again. So we do have to be very careful to say that we have to do 10 unique, 10 different numbers, or ignore any repeated numbers, or something to show that we're not going to use repeated numbers. Okay, step 3. Use the line of random digits below to perform run repetition. It says to copy this onto your paper. So I have already copied this. I'm going to show how do we actually perform the simulation. So what we're going to do is we're going to start marking off numbers that represent passengers. So here's a coach passenger, another coach passenger. We carry over the break here. 70 represents another coach passenger. 99 does not represent anybody. 84 does not represent anybody. 29 is another coach passenger. 7 is a first class passenger. Then there's another coach, another coach, another coach. Let me count how many I have so far. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10. Okay, so when I get to the end of my trial, I usually make a larger bar to say this is the end of the trial. You don't have to write end of trial, but make some kind of mark to indicate that's the end of the trial. Then I go through and make a special mark to indicate a check or an X or a circle or something that that's my first class passenger. And then I'm going to record in trial 1, I have 1 first class passenger. Now you don't have to write this out every time. You could just write 1 because you've already said you're recording the first class passenger. So I can just record the number 1 for trial 1. And then I would go through that process again, counting off 10 numbers between 0 and 1 and 76, and then count how many of those represent first class passengers. Now, if I'm doing a simulation myself, I would want to do about 50 of these to really get enough data to get a good dot plot to show me the simulation results. But often when we're doing these problems in class or even on a test, you might be asked only to do 3 or 4 trials. And that's not really enough to see the long run probability, but it's often just enough to show that you understand the process. So I've shown here that we understand the process, and then in the last part of the problem they give you the results. In 100 repetitions of the simulation, there were 15 times when none of the 10 passengers chosen was seated in first class. What conclusion would you draw? Okay, so a conclusion is always a conditional probability. So I'm saying the probability that I randomly draw these 10 people from out of 76 results in 15 out of 100 trials, giving me this result. So since 15 out of 100 trials resulted in 0 first-class passengers just by random chance, I cannot conclude that getting 0 first-class passengers for the security check is all that unusual. Okay, so I have no reason to think that the first-class passengers are getting preferential treatment. This could have happened. Granted, it only happens about 15% of the time according to the simulation, but it still happens often enough that I don't think that there's preferential treatment going on necessarily.